where we bring you the latest breaking news and trending stories from around the world. Today, we're diving into the incredible story of NASA astronauts Sunita Williams and Butch Wilmore, who recently returned to Earth after being stranded in space for a staggering 9 months. What was meant to be a routine 6-month mission aboard Boeing Starliner spacecraft turned into an unexpected ordeal after a series of critical technical failures. But beyond the headlines, this prolonged stay in space gave NASA a rare opportunity to collect valuable data on the effects of extended microgravity on the human body. Was it just a malfunction that kept them there? Or was this mission a stepping stone for future Mars exploration? Let's break down what really happened and what it means for the future of space travel. Mission overview. What was the goal? Direct hit mission name. Starliner Crew Flight Test, CFT, a critical test mission to validate Boeing Starliner spacecraft for future crewed missions as part of NASA's Commercial Crew Program. Satellite Antenna Objective. The primary goal was to test and certify Boeing CST-100 Starliner spacecraft for human spaceflight to and from the International Space Station, ISS. NASA's Commercial Crew Program aimed to establish a reliable, cost-effective transportation system to the ISS, reducing dependency on Russian Soyuz capsules and adding a backup to SpaceX's Crew Dragon. 3 o'clock planned duration. Initial mission timeline, 6 months. Original plan, the astronauts were supposed to spend 6 months aboard the ISS conducting experiments, system evaluations, and maintenance tasks before returning safely to Earth. Reality. Due to multiple technical malfunctions in the Starliner capsule, the mission extended to an unexpected 9-month stay in space. Man astronaut. The crew. Sunita Williams, veteran NASA astronaut, with over 322 days of spaceflight experience before this mission. Known for her expertise in spacewalks and advanced ISS operations. Butch Wilmore, experienced test pilot and astronaut, with expertise in spacecraft systems and space docking procedures. Satellite scientific goals and research. 1. Microgravity experiments. Study how extended exposure to microgravity affects biological processes, which can inform future Mars and deep space missions. 2. Life support system tests. Evaluate the efficiency and durability of Starliner's environmental control and life support systems, ECLSS, over extended missions. 3. Advanced docking system validation. Test and refine Starliner's docking and maneuvering systems to ensure seamless operations with the ISS. 4. Radiation exposure analysis. Collect data on long-term radiation effects on human physiology, crucial for future deep space travel. Milky Way. Why this mission was crucial. Certification for regular flights. A successful mission would allow Boeing Starliner to join SpaceX's Crew Dragon in ferrying astronauts to the ISS, offering NASA more flexibility and redundancy in crewed missions. Mars Mission Insights. The mission provided an opportunity to study the effects of prolonged space exposure, contributing valuable knowledge for future long-duration missions, including NASA's Artemis program and eventual Mars expeditions. Fire. High stakes for Boeing. Boeing had faced multiple delays and technical challenges with Starliner's development. Success was imperative not only for NASA's mission objectives but also for restoring confidence in Boeing's space capabilities. This mission was supposed to be a straightforward test and validation flight, but what followed was an unexpected journey that reshaped NASA's understanding of prolonged human spaceflight. What went wrong? Why were they stuck? What began as a routine 6-month mission quickly turned into an unexpected 9-month ordeal due to a combination of technical malfunctions, safety concerns, and system failures that left astronauts Sunita Williams and Butch Wilmore stranded in space. Here's a breakdown of the key issues. Fire. 1. Thruster malfunctions, the biggest concern. Problem. Shortly after docking with the ISS, engineers detected that 5 out of 12 of Starliner's maneuvering thrusters were malfunctioning. Impact. The thrusters are crucial for safely navigating and adjusting the spacecraft's position during re-entry. A malfunction during descent could have led to a catastrophic failure, making it unsafe for the crew to return. Satellite 2. Propulsion system glitches. Leak detected. A minor fuel leak was identified in the propulsion system, raising concerns about Starliner's ability to generate sufficient thrust for a safe re-entry. Cause: engineers suspected that the leak was due to a seal failure in one of the propellant lines, which required extensive remote diagnostics and recalibration to mitigate. Why it was dangerous: even a small leak in a spacecraft's propulsion system can destabilize its trajectory during re-entry, putting astronauts at risk. Brain 3. Software bugs and navigation errors. Navigation system failure. Starliner's onboard navigation system experienced software glitches, affecting its ability to accurately calculate re-entry trajectories. Software patching. NASA and Boeing engineers had to upload multiple software patches to fix these issues while the astronauts remained on the ISS. Risk factor. If navigation systems had failed during re-entry, it could have resulted in the spacecraft missing its landing zone or re-entering the Earth's atmosphere at a dangerous angle. Stopwatch 4. Safety checks and delays. Repeated diagnostics. NASA opted to extend the astronaut stay while engineers conducted repeated remote diagnostics to ensure all systems were functioning properly. Conservative approach. Given the high-risk nature of spaceflight, NASA chose a cautious approach, delaying the return until they were 100% confident the spacecraft could complete a safe descent. Unprecedented extensions. The initial 6-month mission stretched to 9 months as engineers worked around the clock to troubleshoot issues and conduct additional safety checks. Stop sign 5. Risk of space debris and mission complexity. Increased collision risk. Due to the extended stay, Starliner had to adjust its orbit multiple times to avoid potential collisions with space debris. Fuel constraints. Each maneuver consumed additional fuel, further complicating the mission's return plans. Lightbulb 6. Manual override risks. Potential manual return. There were brief discussions about using manual controls to return to Earth if the software and thruster issues couldn't be resolved. Why it was avoided. Manual re-entry is an extremely high-risk option and was deemed a last resort. Fortunately, engineers managed to restore system stability before such drastic measures were required. Rocket 7. Time was running out. Life support concerns. Life support limitations. Starliner's Environmental Control and Life Support System, ECLSS, was designed for a 6-month mission. While it was extended to support 9 months, engineers had to closely monitor carbon dioxide scrubbers, oxygen levels, and waste management systems. Impact of 9 months in space. What NASA learned. Muscle and bone deterioration. Prolonged exposure to microgravity causes astronauts to lose up to 1 to 2% of bone mass per month. Sunita and Butch were subjected to additional bone scans, which provided crucial data to help mitigate this issue on longer missions. Vision and brain pressure changes. Microgravity affects the shape of the eyeballs and increases intracranial pressure, often causing visual changes. Their extended stay allowed researchers to measure the long-term progression of these changes. Cardiovascular adaptation. The astronauts underwent regular cardiovascular monitoring, helping scientists understand how prolonged space travel affects heart function, blood flow, and circulation. Immune system monitoring. Microgravity weakens the immune system. By analyzing blood samples over time, NASA hopes to develop new methods to boost astronaut immunity during deep space missions. Psychological challenges. How they coped mentally. Isolation and stress. Staying isolated in a confined environment for 9 months tested their mental resilience. Daily routines, virtual family interactions, and structured exercise schedules helped maintain psychological stability. Space fatigue and anxiety. Despite their training, astronauts experience space fatigue, a condition marked by mental and physical exhaustion due to long periods of microgravity and isolation. NASA psychologists monitored their mental health to study its long-term effects. Scientific gains, why this was a blessing in disguise. Mars and beyond, the extended stay provided NASA with rare data to simulate potential challenges for future Mars missions, where astronauts may spend over a year in space. Advanced life support systems, scientists collected data on how existing life support systems perform over extended periods, aiding in the development of more reliable systems for future missions. Radiation exposure studies, the astronauts' prolonged exposure to space radiation gave NASA additional insights into developing better shielding technology for deep space exploration. The journey home, how they finally returned. Final clearance. After multiple rounds of diagnostics and system checks, Boeing engineers confirmed Starliner was safe for return. Re-entry and landing. Sunita Williams and Butch Wilmore successfully landed in the desert of New Mexico, completing their unexpected 9-month mission. Post-mission quarantine. Upon returning, they underwent extensive post-flight evaluations to assess the long-term physiological effects of their extended stay. What this means for the future of space travel. Mars simulation success. This unplanned extended mission serves as a real-world case study for Mars missions, helping refine plans for multi-year space expeditions. Improved Starliner systems. Boeing is working on major upgrades to Starliner's propulsion and guidance systems to prevent such incidents in the future. Paving the way for Artemis missions. NASA will apply lessons from this mission to ensure the safety of astronauts during future Artemis missions to the Moon and beyond. And that's a wrap on this incredible story of resilience, innovation, and discovery. Sunita Williams and Butch Wilmore's 9-month space odyssey wasn't just a technical challenge, it's a glimpse into what the future holds for humanity's journey to Mars and beyond. As NASA continues to prepare for deep space exploration, every lesson learned brings us one step closer to unlocking the secrets of the cosmos. If you enjoyed this deep dive, don't forget to like, share, and subscribe to the Viral Times for more captivating stories from around the world. See you next time.